Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 11 of lesson number 10, Gravitation, and this is going to be the last part for the lesson where we will be doing the summary. It's a kind of revision that we will be doing for the whole lesson, and then we have 22 exercise questions to discuss. Okay, so like I will be telling you the answer for that, but before that, like I will even want you to like come up with the answer on your own, because now we have studied this lesson in the last 10 parts and everything. I was never like I have to complete it, so I was in hurry, right? I have explained all the concepts properly, right? And you have even taken proper notes, you were revising in each and every part. So today, while we start with the exercise, there might be some questions where you can have doubt. I'm not saying that you'll be able to like solve all the 22 questions, but at least you know the concept, you can try to answer it. Okay, I'll be giving you the answers, I'll be like dictating you. You have to listen to it, understand it, and after that you have to like make your own notes on it. Okay, and there are many numericals as well, which I will be like telling you the formula that you need to apply and how you need to exactly do that. So I'll be helping you in that way as well. Okay, now before that, as you all know that before we start with the lesson now, because today we will be doing the summary discussion itself, right? So doing the summary discussion, I before we start with that, I like we will be doing the revision that we do the same way. Okay, I'll be showing you all the slides and all, so that will be better for like each of you to understand the concepts properly, and a proper revision will also happen, right? So now I want each one of you to please revise whatever like notes you have taken, because that is also very important, right? So please revise it, everyone. I hope every one of you have started revising it. You need to go through each and every part that you have taken note of. Okay. So we have started the lesson by discussing on the basics of gravitation, what exactly gravitation is and who came up with the concept of gravitation, how he exactly came up with the concept of gravitation and everything, right? So please go through this, and now you have to explain it to yourself, and when you do that you'll be confident enough that you know the concept. After this, we discussed on one activity, and I hope every one of you might have tried doing it. Then after this, we discussed on universal law of gravitation, which is very important. So please go through it, everyone. So here is the proper derivation and you should be able to derivate it. I hope you all are going through it. Like here we have the value of the G along with the, you can say, SI unit and everything which has been given. Then we discussed about Sir Isaac Newton, who he was, like where he was exactly born, what he was exactly doing, how he studied, what was his father, like what his father did, and lastly, like how he came up with so many activities and experimentations further. So here we have the different activities that Newton has performed. I hope you all are going through it. Then we discussed on this example like how to calculate the force exerted by the earth on moon through the given information, right? Then we discussed on the three laws that we have even discussed in the last lesson that we have studied, right? So please go through it, everyone. After this, we discussed on like again an example. So here we have actually used the formula that we had, right? So I want each one of you to please go through it as well. After this, we discussed on the importance of universal law of gravitation. So I want you all to please go through it, as this can also be asked. Like if you are asked to write about the universal law of gravitation, you can add on writing the importance of the universal law of gravitation as well there. Okay. Then we discussed on free fall, and the proper explanation for free fall has been given over here, where they have even explained us with respect to acceleration due to gravity. Okay. I hope you all are going through it, because after this we have like how exactly acceleration due to gravity is been like you can say formulated, right? How the equation comes on. So we'll be we'll be going through the derivation part as well for that. Then here we have the derivation for acceleration due to gravity. After this, we discussed on like how to calculate the value of G on the basis of the information given. So I want you all to please go through it. Then after this, we discussed on motion of objects under the influence of gravitational force of the earth, right? So I want each one of you to please go through it quickly. So here we have the proper equation, like the three different equations which have been given. I want you all to please go through it quickly. After this, we discussed on an example, like there are two different examples, right? So just go through it, everyone. After this, we had one more example where we have actually applied the three different equations, right? So please go through this as well. After this example, we discussed on mass and weight, because whenever it comes to force, mass and weight, and along with that, we had one more concept as thrust and pressure, right? So all those concepts are also very like important, which I want you all to quickly revise. So after mass, we discussed on weight. So everyone, please go through the slide quickly. So after weight, like we have more explanation on it. The SI unit of it and like many other parts with respect to it. Then we discussed on like what will be the weight of an object on moon, right? And we discussed it through this table that has been given, where we have the mass and the radius of the earth and the moon, right? So please go through the derivation part properly, everyone. After this, we discussed on two different examples on the same. So please go through it, everyone. Then here we have like thrust and pressure, which has been explained very well through two different situations, right? And here we have like mostly the questions that they have asked to like make us aware about what exactly thrust and pressure is. Okay. So here we have the situation 2 that has been given, and I want you all to please be quick with it. Then after this we discussed on the formula of thrust. I want you all to please go through it quickly as well. Then we discussed on one example again how to calculate the part, like if you get a question on calculating the like you can say thrust and pressure or the masses, like how the formula will be applied and how will you use it properly, right? So make sure you go through it properly. Then we, like the solution is the same. We discussed on pressure in fluids, right? So I want you all to go through it as well. So sorry. Where were we? Yeah. So after pressure in liquid, we discussed on buoyancy in detail, and I want each one of you to please go through this buoyancy part as well. Buoyancy again is a very important topic. Then after buoyancy, we discussed on this activity 10.4 where we have the proper explanation which has again been given over here. Then we discussed on like why objects float or sink. So the reason has been given. Then we discussed on Archimedes' principle in detail. And I want you all to go through this Archimedes principle because this is also again very important, right? So the important information has been provided over here. Then we discussed on like who exactly Archimedes is, right? So please go through it everyone as well. Then we discussed on relative density in detail, right? And here we have the formula for calculating the relative density as well, which has been given, right? So here we have an example given for calculating the relative density. I want you all to be quick with this as well. It's just that you need to like apply the formula for relative density, right? Then we have the summary which has been given over here, and I want each one of you to please go through it quickly. So now we have the exercise questions which have been given. The first question is, how does the force of attraction, force of gravitation between two objects change when the distance between them is reduced to half? So what do you think for this? How will it change? See, according to universal law of gravitation, the gravitational force of attraction between any two objects will be like capital M and small m, and we know that it is like the force is going to be directly proportional to the product of their masses and inversely proportional to the square of the distance between them, right? So according to the question, if the distance is reduced to half, it means the r that we have, the square of the distance between them, that r will be r divided by 2. So when you do that, you will get the like force as 4F, and hence you can say if the distance is reduced to half, then gravitational force becomes 4 times larger than the previous value. What I said, if the distance is reduced to half, because we have r square, right? So r divided by 2 the whole square, so it will become 4. So it means when we are reducing it to half, the gravitational force will become 4 times larger than the previous value. Got it? Then we have the second question as, gravitational force acts on all objects in proportion to their masses. Why then a heavy object does not fall faster than a light object? So see, any object, like be it any object, all objects are going to fall on the ground, right? And that fall is going to be with constant acceleration, which is called as acceleration due to gravity. Okay, so it means all objects fall on ground with constant acceleration, called as acceleration due to gravity, and it is going to be constant. Okay, it is constant and does not depend upon mass of an object. What it does not depend upon? Mass of an object, and hence heavy objects do not fall faster than light objects, because it is not going to depend upon the mass, right? They are all going to fall with respect to acceleration due to gravity, and that is going to be constant. Okay, so I hope you all have understood this. Then we have the third question, where the magnitude of the gravitational force between the earth and 1 kg object on its surface, like, is been given, like mass of the earth is 6 into 10 raised to 24 kg and radius of earth is 6.4 into 10 raised to 6 meters. So in this case, how are you going to calculate? First you will write that given is mass of the body is 1 kg, mass of the earth is 6 into 10 raised to 24 kg, radius of earth is 6.4 into 10 raised to 6 meters, right? And we have to find the magnitude between the earth and the body, so we can calculate that using the formula F is equal to capital G m, mass of the like product of the masses, upon r square. Okay, so you know that mass of earth is capital M is 6 into 10 raised to 24 and small m is 1 kg, right? Divided by the distance, that is the radius, has also been given. So it's very easy, and when you calculate, we know that the capital G is also a gravitational constant whose value is 6.67 into 10 raised to minus 11, right? So once you apply the formula, you will get the answer as 9.8 Newton approx. Got it? So nothing to worry, like you don't have to do anything. It's just that whatever has been given, you have to apply the formula F is equal to G, product of their masses, capital M into small m, upon r square, radius square. So everything has been given over here. Okay. Then the fourth question is, The earth and the moon are attracted to each other by gravitational force. Does the earth attract the moon with a force greater or smaller, or the same as the force with which the moon attracts the earth? Why? So now if you go according to the universal law of gravitation, we have studied that two objects attract each other with equal force but in opposite direction. How do they attract each other? With equal force but in opposite direction. So the earth attracts the moon with an equal force with which the moon attracts the earth. So the force applied will be equal, but it's going to be in opposite in direction. Okay. Then we have fifth question as, if the moon attracts the earth, why does the earth not move towards the moon? So here we know that earth and moon experience equal gravitational force from each other, right? The gravitational force between the earth and the moon is going to be equal. However, the mass of earth is larger than the mass of the moon. So because the mass of earth is larger than the moon, it accelerates at a rate lesser than acceleration rate of the moon towards the earth. So for this reason, earth does not move towards the moon because of the mass of the earth is larger than the mass of the moon, and the rate of acceleration will be lesser as compared to the acceleration rate of the moon. Okay. Then we have sixth question as, what happens to the force between two objects if the mass of one object is doubled? So for answering this, we know that from universal law of gravitation, force exerted by an object m by mass is given by F is equal to capital G mass of product upon R square. So when mass of the object is doubled, in that case the small m will be 2. So as the mass of any one of the object is doubled, the force will also double. What will you write? If the mass is doubled, the force will also get doubled. Then the second question under this is, the distance between the object is doubled and tripled. So see, we know that force is inversely proportional to the distance between them, right? So if the distance between two objects is doubled, then the gravitational attraction between them will be reduced, you can say reduced to 1/4 of its original value, because it is inversely proportional, right? So if it is tripled, then it will be like reduced by 1/9 of its original value. So mass will get doubled, but distance will get reduced. Okay. Then the third question that we have is, the masses of both objects are doubled. So we know that force F is directly proportional to the product of their masses, right? So if both the masses are doubled, then the gravitational force of attraction becomes 4 times the original value. So if mass is getting doubled for one object, it is going to double 2 times. If it is getting doubled for both the object, it will get doubled 4 times. Getting it? Then we have seventh question as, what is the importance of the law of gravitation? Now we know that the motion importance is like the motion of moon around the earth, motion of planets around the sun, force that is responsible for binding us to the earth, right? So there are many importance that we have studied. You can write the same over here. Then what is the acceleration of free fall? So you can write that acceleration of free fall is the acceleration produced when a body falls under the influence of a force of gravitation alone, and it is denoted by small g, okay, and whose value is 9.8 meter per second square. Okay. Then after this we have ninth question as, what do we call the gravitational force between the earth and an object? So gravitational force between the earth and an object is known as weight of the object. Okay. Now we have 10th question as, Amit buys few gram of gold at the poles as per the instruction of one of his friends. He hands over the same when he meets him at the equator. Will the friend agree with the weight of the gold bought? If not, why? And there's a hint given that the value of G is greater at the poles than at the equator. So we know that weight is equal to mg, right? Mass into acceleration due to gravity. So the value of G is greater at the poles than at the equator, and therefore gold at the equator weighs less than at the pole. Okay, so gold at the equator will weigh less than at the poles, and hence Amit's friend will not agree with the weight of the gold bought because of the difference of the equators and the poles. Okay, then we have 11th question as, why will a sheet of paper fall slower than one that is crumpled into a ball? See, when you crumble a sheet of paper into a ball, the density increases in that case, and hence resistance to its motion through the air decreases. What? Resistance to its motion through the air decreases, and it falls faster than the sheet of paper. Got it? Then we have 12th question as, gravitational force on the surface of the moon is only 1/6 as strong as gravitational force on earth. So what is the weight in newtons of 10 kg on the moon and on the earth? So now we know that weight of object on the moon is 1/6 into weight of an object on earth, and we know the formula for weight is m into g, that is mass into acceleration due to gravity, right? So weight of 10 kg object will be 10 into 9.8, because we know that acceleration due to gravity is constant, right? So 10 into 9.8, and you will get the answer as 98 Newton. And the weight of the same object on the moon will be 1.6 into 9.8, because it is going to be 1/6 into mass of the object into acceleration due to gravity, right? So 1.6 into 9.8, and you will get the mass as 16.3 Newton. Okay, then we have 13th question as, a ball is thrown vertically upward with a velocity of 49 meter per second. Calculate the maximum height to which it rises, the total time it takes to return the surface of the earth. So we know the equation as v square minus u square is equal to 2gs, where u is the initial velocity, f is the final velocity, s is the height achieved by the ball, and g is acceleration due to gravity. Now because we know at maximum height, the final velocity of the ball will be 0, right? And u is equal to 49 meter per second. And because there's an upward motion, it's the acceleration due to gravity is going to be negative, so it will be minus 9.8 meter per second square. Okay, so you have to put the value in the equation and then calculate the answer. You will get the answer as 12.122.5. Okay, after that you will use one more formula as v is equal to u plus gt, and that is how you will come to know the answer. Okay, then again we have here numerical. A stone is released from the top of a tower of height 19.6 meter. Calculate its final velocity just before touching the ground. So over here we will use the formula, same formula again, that v square minus u square is equal to 2gs. So u is the initial velocity of the stone, which is 0. V is the final velocity of the stone. S is the height of the stone, that is 19.6. And we know that small g is going to be 9.8 meter per second square. So we have to put the values in the formula. V square minus u square is equal to 2gs, and you will get the answer as 19.6 meter per second. Okay. Then we have 15th question as, a stone is thrown vertically upward. Now vertically upward, so g will be negative, with an initial velocity of 14 meter per second. Taking g as 10 meter per second square, find the maximum height reached by the stone and what is the net displacement and total distance covered by the stone. So again you will use the same equation, v square minus u square is equal to 2gs. Okay, so the values are been given, and because it's in upward motion, acceleration due to gravity will be negative, so it will be minus 10 meter per second square, because here we are taking the value of g as 10, right? So depending on that you have to find out the value. Okay, then we have 16th question as calculate the force of gravitation between the earth and the sun, given that the mass of the earth is 6 into 10 raised to 24 kg and of the sun is 2 into 10 raised to 30 kg. So the average distance between the two is 1.5 into 10 raised to 11 meter. So according to the question, if you go, you have mass of the sun, which you are going to represent as ms, that is equal to 2 into 10 raised to 30 kg. Mass of earth, that is me, is 6 into 10 raised to 24 kg, and distance r is radius is equal to 1.5 into 10 raised to 11 meters. You will write the given and you will use the gravitational constant over here. F is equal to gravitational constant product of their masses upon radius square. Okay, and you will get the answer as 3.56 into 10 raised to 22 Newton once you solve it. So it's very easy, again you just have to put the values. Then we have the question as a stone is allowed to fall from the top of the tower 100-meter high, and at the same time another stone is projected vertically upward from the ground with a velocity of 25 meter per second. Calculate when and where the two stones will meet. So over here you will be using like initial velocity, you will keep it 0. Then you will change the initial velocity to 25 meter per second. Like that way you have to do it. See, let T be the point at which two stones meet and H be their height from the ground. So height of the tower is capital H, that is 100 meter. That has been given already, right? So it is clear from the question that we need to calculate time when two stones meet. So after calculating time, we can also calculate the distance. Okay. So for that, we need to consider the stone which falls from the top of the tower. The initial velocity is going to be 0. So distance covered by the stone at time t will be like ut plus half gt square. You're going to use that and you have to put the values over there. Okay, it's bit you can say tricky, but please try to solve it, and if you're not able to, I'll give you the solution for it. Okay, then we have 18th question as a ball thrown up vertically returns to the ground to the thrower after 6 seconds. Find the velocity with which it was thrown up. So for that you will use the equation v is equal to u plus dt. Then for calculating the maximum height it reaches, you have to use the like equation s is equal to ut plus half at square, and lastly its position after 4 seconds. So in that case you will use the formula again as s is equal to ut plus half gt square. Okay, so I just told you the formula that you need to use, try to solve it. Then in which direction does the buoyant force on an object immersed in a liquid act? So we always know that it is going to act in the upward direction, right? Then why does a block of plastic released under water come up to the surface of water? Because we know that for an object immersed in water, two forces act on it. First is the gravitational force, which tends to pull the object downward, and the buoyant force that tends to push the object in the upward direction. So in this case, because the buoyant force is greater than the gravitational pull, this is the reason that plastic block comes up to the surface as soon as it is released, because the buoyant force is more over here. Okay, then we have 21st question as the volume of 50 kg or 50 grams of substance is 20 centimeter cube. If the density of water is 1 gram cubic centimeter, Will the substance float or sink? So over here, see, you will calculate the density first for that. So density is equal to mass upon volume, right? Mass is 50, volume is 20, and you will get the answer as 2.5 gram cubic centimeter, right? So because the density of the substance is more than density of water, that is 1 gram cubic centimeter, the substance will sink. Got it? The last question that we have is, the volume of a 500 gram sealed packet is 350 centimeter cube. Will the packet float or sink in water if the density of the water is 1 gram cubic centimeter? What will be the mass of the water displaced by this packet? So again we will do density is equal to mass upon volume, where mass is 500, volume is 350, and we get the answer as 1.428 gram cubic centimeter. Okay, so because the density of the substance is more than the density of water, that is 1 gram cubic centimeter, it will sink in water. Got my point? Now there are 2-3 questions that you might be confused with. I know. What you can do is, like, you can try to solve with the formula that I told you, and then we can discuss on it further as well. Okay, so I'll end up with the lesson over here, and I hope that every one of you have understood whatever we discussed in the whole lesson, gravitation. Because in the next part I'm going to start with a new lesson, so everyone please make sure that you understand this lesson properly, you are able to answer the questions properly. Okay, and after I end it, make sure like you have gone through it properly and you're trying to write the answers in your own words. That is what I feel is very important for you now, so make sure you do that. Okay, so I'll be continuing with the next part. Okay, like next lesson in the next part. Thank you everyone.